Student, this is first year physics, chapter 2, scalar and vector quantities. All physical quantities we can classify or distribute into two types. One scalar quantity and other vector quantity. How can you make difference between the scalar and vector quantity? You can see this slide. A scalar quantity has only magnitude. Magnitude means number. Of course, to measure a quantity, we require the parameter. For example, if we want to measure the distance, we use meter. And if we want to measure the time, we use second. So it means that unit is understood. But if the specification of the quantity required only magnitude, then we categorize those quantities in scalar quantity. Specification means complete explanation without any confusion. For example, we say to the shopkeeper, give us 2 kilogram rice. So we don't need to tell the direction. And he can understand, well, what you need. But if an aeroplane pilot informed to the airport that his plane is 10,000 feet away and 10,000 feet high from the airport, so the location of the aeroplane will not be clear because the direction is not mentioned. So it means that for the complete specification, direction must required with the magnitude. Those quantities are called vector quantities. You can see on the slide that a vector quantity has both magnitude and direction. So very simple in definition and simple to understand. So several examples are here mentioned on this slide. You can note down the example of the scalar quantities: length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work done, and power. These all are scalar quantities which required only magnitude, not required direction. While the examples of the vector quantities are displacement, velocity, acceleration, momentum, force, lift, drag, thrust, weight. So these all are required the displacement. Here I want to show clearly that by taking one example, that why these quantities, how can we categorize? For example, I say distance. So distance and displacement. Distance and displacement. You can see here a ball is thrown upward in air from the point A and fall on the ground at point B. And here you can say that someone say walk from the point A and ended its journey point B. Similarly, a person say or an object is moving and starting its journey from the point A, and this is say the point A, and ended its journey at the point A again. So in these three examples, the distance and the displacement. Distance we say the scalar quantity, and displacement we say the vector quantities. So if there is some separation from the point, one point to the other point, so starting point is A and ended point is B. This is say that you cannot say B to A. You will have to say A to B. A to B, and there is a vector sign over it. This is A to B, and this vector is also A to B. The distance from one point to another point, or the separation from one point to another point in a specific direction. What is the direction? Is that A to B. If we say moving horizontally along x-axis, so towards x, or if we assign exact direction, so we can say that this person is moving towards east. Towards east, it means that we cannot say that the person is moving from B to A. We cannot say B to A. B to A is equal in magnitude but opposite in direction, towards west. So from these examples, we say that displacement over here is, say, 0, because in this example that a person is moving and covering the distance in a circle, starting from point A and ended its motion again at point A. So the displacement is, say, 0. Displacement is, say, 0. But the distance, traveling distance, is the total say circumference of the circle. Total circular path of the circle is the total covered distance. Mathematically, you can say that by the circumference is equal to 2 pi r. 2 pi r. If we want to calculate the distance, how much? So we have to calculate the total circular path of this journey, which is equal to 2 pi r. But if you say the displacement here, that is 0. Similarly, in other example, that a ball is thrown from the point A in the air and fall on the ground at B. So how much ball displace from A to B? That is the displacement. And how much ball remain in air and covered this distance, or the total traveling path of the ball, is the distance. So student, we can say that this, for the distance, only the magnitude or a number is enough. For example, 2 meter, 20 meter, 2 kilometer. But for displacement, that must have some starting point and ended its motion another point, and starting from A to B, like that, in any specified direction. That's why the displacement is the vector quantity, while the distance is the scalar quantity. So it's clear that all these examples you can explain. Scalar and vector, the differences and examples in this slide, you can read that, or you can see that a quantity that can be measured is a physical quantity. That's why there are several quantities. Some quantities are, say, simple and basic quantities, like there are 7 basic quantities in physics, length, mass, time, temperature, etc. 7 basic quantity, and other quantity which we derive from the say single or 2 or more than 2 quantity. By combining the 2 or more than 2 quantity, those are called derived quantities. For example, say this speed, distance over time, so say volume, say density. So these quantities are derived quantities. So all are these are all called the physical quantities. Physical quantity consists of a magnitude and unit and some time direction. Scalar and vector quantities are written over here in very clearly. You can learn this definition to recall in the exam or in test. Scalar quantities are those physical quantities that are expressed only by their magnitude. As I have told you, and I have explained you that scalar quantity, why that required only the magnitude. for their specification. You can add one word here, that for their complete specification it is understood word. Similarly, the vector quantity requires both magnitude and direction. Completely express them. Thus, the difference between the scalar and vector is the presence of the direction. So you can keep in your mind that if we talk about only magnitude, that magnitude will present in both the quantity scalar and vectors, but the vector quantity must have the direction. Therefore, the difference between the scalar and vector is only the presence of the direction. So in this slide only, that is for you that that slide, on this slide, that scalar quantity clear definition is written over here again. You can note down. You can some student need to be learn it to write in a proper way in exam. So when there is a question about the definition of the scalar quantity, you need very specified word. You don't need explanation. So here one thing is very clearly example. If we say that the mass of a bag is 5 kg, it has complete meaning. Mass of a bag is 5 kg means that we don't need to say the direction. If we say the direction with it, mass, so it will be confusion create, and it will create the confusion, and that will be difficult to understand. It has complete meaning, and we are completely expressing the mass of a bag. Similarly, if we are expressing the quantities completely with the magnitude only, so that means we represent a scalar quantity symbolically by an English letter. For example, M denote mass, T for time, D for distance as a speed. So the alphabets we use to explain like that. Sometimes we use the D for distance and D for displacement. Somewhere in physics the register symbol for the distance is S, but for the speed is V. So here, as for speed, that's true and easy to understand. But in physics, the register symbol for the speed and the velocity is V, and for the distance is S. In some books you can see that X also, but I think in your book it is S, symbol S for distance, and M for mass, T for time. It's okay. And regarding subtraction, multiplication and division of the scalar quantities are very easy and simple mathematical rules and methods apply. For example, 2 plus 2 is 4, 2 minus 2 is 0, 2 multiplied by 2 is 4, 2 multiplied by 3 is 6. 2 plus 3, you can say 7. Uh, as compared to the addition and multiplication of the vector quantities, it is easy, and you know from your lower classes. So similarly, you can say that vector quantities definitions are clearly for your convenience. I showed on this slide. You can copy down, or you can take a snapshot, or you have to learn this definition clearly to write in your test and exam, that the quantities are those physical quantities required both magnitude and direction. I have given you the detail of this, and some example I show here, that if we say that the space was stone 10 meter, the first question that arise will be in which direction. Of course, if you throw a stone in air, so first the question arise over here, either where, either horizontal or vertical, towards north, towards east, toward west. If they're horizontals, either toward east or west. If they're you thrown upward, definitely it will that will be the direction north. And when the stone return back to the ground, so that will be the south. So it means that the complete sense only be possible if you say that I've thrown a stone towards east horizontally, or I throw a stone upward, or you say the vertical upward. You can use the proper direction, that I throw a stone towards north. So which means that the direction. Thus, we need the following three parameters. Right? This is summarized summary of this all. Explanation and lecture about the scalar and vector quantities. That three things we required: the numerical value, measured quantity. There is like 2 meter. So 2 is a numerical value. 20 meter. 20 is a numerical value. 20 kilogram. 30 kilogram. So 2 hours, 2 seconds. So number shows the numerical value, which is the quantity of magnitude of a quantity. Magnitude means the number means the numerical value. And the unit in which the quantity is measured. Unit is something parameter. As I have told you that when you have to measure the distance, you use meter, or if you have to measure the length, you use meter. If you have to measure the mass, you use kilogram. So it means that the parameter in which the quantity is measured giving you the sense. So that is important. The second thing is, which is understood. But when you say the magnitude and unit in the first scalar, magnitude, unit and direction. So third important thing is the direction. So I hope you understand about the scalar and vector in quantities in detail. So here again on the script that the examples of the vector quantities are over here for your convenience. You can see very well about that. So student, this is the lecture about the scalars and vector quantities and introduction of the scalar vector quantities, how many things required for that, correct definition, and what do you mean by the magnitude, what do you mean by the physical quantity, and why this we categorize some quantities are in scalar class scalar, and why we keep some quantities in vector, and what are the three important things required for the scalar vector. Hope you understand this lecture. Inshallah, the other things related to this chapter I'll specify in the next class. Thank you very much.